There's a gas in our atmosphere that's so toxic to breathe, yet without it, none of us would be even alive. Not only that, just by few kilometers apart in the atmosphere can make the tremendous change in the nature. Just in 10 to 20 kilometers in altitude make the difference between the poison and the savior.
In 1839, Christian Friedrich Schubert, a German scientist, was experimenting with electricity. At University of Basel, he was trying to perform an experiment called electrolysis of water. Basically, he took H2O and placed into a beaker, added metal rods and wired them up to a platinum zinc battery.
The objective of this experiment was to decompose the hydrogen and oxygen from the parent water molecule. In this case, we have to give a potential difference where I use battery which is connected to two electrorods. It converts H2 and O2. But in original experiment, Schubin what he did was he accidentally gave in a higher potential difference.
But soon he noticed something strange. After a spark, sharp, pungent smell, the same smell he sensed after a thunderstorm, he realized this was a new kind of gas, something no human had described before.
He named it ozone, from a Greek word ozine, meaning to smell. He himself reported that smelling or inhaling the gas create a great irritation in lungs and eyes. Scavengers has discovered a gas that is both incredibly useful and extremely dangerous. So here's the paradox. How can one gas both kill us and save us?
In 1857, nearly 30 years later, a German engineer named Werner von Sieben decided to trap that gas inside a vessel. He built the world's first ozone generator using electric spark to split oxygen and create ozone on demand. But Seaman was clueless. The big question was, what could you do with this unstable, mysterious gas? Around the same time in France, Louis Pasteur has a mind-bending discovery. He proved something surprising. Tiny invisible microbes were the real cause of infection. Suddenly, doctor realized that surgery itself can kill the patient because their instruments were dirty and full of germs. This was the problem. Surgery saved lives but also spread deadly infections. Doctor needed a way to kill germs. Pasteur's work triggered a race for sterilization. In 1870, Dr. C. Lender had a brilliant idea. Using Siemens generator, he applied ozone for disinfection and sterilization. He cleaned surgical instrument and even treated wound within it. And the ozone with its sharp biting smell, reputed as super oxygen, seems like the perfect weapon to fight against germs. He pushed ozone from theory into real life. In an era where most of the surgeons still operate barehanded, Lender was using an invisible gas to fight microbes no one could see.
It was revolutionary and reckless. Ozone is so toxic to breathe and Lender has no idea about its risk. But his experiment was a breakthrough. Ozone once a curious smell after the lightning to a human invention, to a medical first tools against infection. Simon built the machine, Pasteur revealed the problem, and Lender dared to try it. Together they showed how a strange gas become a perfect weapon against the invisible killer of their ages. What began as a pungent smell from a chemist lab to become a global solution for industry and public health. Not only sterilization, there are many applications of ozone in medical use.
Ozone is a very strong oxidizing agent, so this kills most of the widest spectrum of microbes. So OUAT conducted 2 studies on this. What they did, they used ozonated water along with antibiotics. In both these cases, this clearly suggested they combinedly they are very effective in treating these bovine urinary infections.
Here's another example. The saline water that a patient takes in hospital bed has ozone in it. In fact, ozone is so great in disinfection that it's also present in packaged drinking water that we use in daily life. Well, so what is this, sir?
Okay, fine. So this is the ozonated water dispenser. It intakes air, and this air has got oxygen. This oxygen is converted into ozone. Okay.
How the oxygen is converted?
Okay, fine. The nice question. So inside it, there is a tube-like component is there. It intakes air. And this is subjected to a 5000 volts.
Okay.
So inside it, cold plasma is built up. So with this cold plasma, oxygen is converted into ozone. Okay. So this also in a larger scale, same principle, using same principle, municipalities, they purify their water, drinking water and supply.
So can we see ozone?
Yeah, ozone is normally invisible, but we can see when we bubble it through water, you can see it.
Okay.
So let us see.
Wow.
Okay. Acha, can you sense something?
I feel a strong smell.
Okay. That is smell of ozone.
Okay.
Oxygen is doesn't have any smell, but ozone has got a very characteristic strong pungent smell.
Okay, that's just like right after the thunderstorm or lightning.
Exactly, because naturally ozone is generated when lightning strikes.
Okay.
Same, high voltage.
So ozone is a true blessing, with its countless use to humanity itself. Even it is directly helping to living organism by absorbing harmful UV light from sun. How so? With a layer of it surrounding the earth trap those radiation. And how we know that it surrounds the earth's atmosphere? Let me say you a story. Our sun gives us life, but also sends deadly ultraviolet radiation. Radiation strong enough to damage DNA, cause skin cancer, and wipe out life as we know it. So what's saving us? A thin seal of gas, ozone, floating 20 km above our heads. In 1913, 2 French scientists, Charles Fabry and Henry Vision, were splitting sunlight through prism. However, the ultraviolet part was absent. Something in the sky was absorbing it. That something was ozone.
While studying the spectrum of sun ray, people observed that it contains all the visible light, and in UV region, which is from 100 to 400 nanometer, there is a particular region in 200 to 300 where the intensity is low, or we can say that it's missing when we see it from Earth. So why is it so? That was a big question for everyone. Later, when ozone was discovered in the laboratories and its spectrum was taken, and it is seen that this ozone molecule actually absorbs in this 200 to 300 region. Actually, this spectroscopic knowledge is used by Gaussian, where he compared the intensity of light which is not absorbed by ozone and the light which is the UV light that is absorbed by ozone. The intensity he compared to say the amount of ozone in the atmosphere. That was really a completely new and marvelous thing.
A British scientist, Gordon Thomson, built a machine to measure this gas from the ground. What he found was strange. Ozone wasn't evenly spread. It was thick over poles and thin near the equator. And it changed with seasons. Thomson built a global network of detectors. His device is so reliable that we still use it today. In fact, we measure ozone in Thomson unit. Isn't that interesting? How important ozone is to us. But the curse of ozone was from food preserving itself. Back in 1950s, food preserving was a serious issue. What people used was a ice box. There will be an iceman who will deliver a block of ice from house to house and place it in an insulated box. It was fine, but the only limitation was the water drips across the house. So chemists in United States created a new kind of molecule. These are the molecules that never existed on Earth before. They named them chlorofluorocarbon or CFCs. Because they consist of one or more carbon atom along with some chlorine and fluorine atoms. These molecules are very successful. CFCs became the main coolant in refrigerator and in air conditioner. But the problem was in 1974, where two chemists Mario Molina and Sherwood Rowland realized this miracle chemical of modern age, CFC in refrigerator, hairspray and air conditioner, drifted into stratosphere. Their sunlight tore them apart, releasing chlorine atom, and each chlorine atom could save thousands of ozone molecules. They warned the world this could thin ozone layer dramatically. But first, many scientists thought, sure, this will take centuries. We got time. But within 10 years, three British scientists looked at the ozone reading. And what they saw didn't make any sense. Ozone wasn't thinning slowly, it was collapsing. There was a massive hole had opened over Antarctica. Here's the twist. NASA satellites had already seen this. But the numbers were so extreme that computer deleted them as errors. It took Farman old school Thomson spectrophotometer to prove it was real.
This was the first time humanity realized they have broken the atmosphere.
The response was action. In 1987, the Montreal Protocol was signed, banning CFC worldwide. It became the most successful environmental treaty ever.
And the best part, it worked. The ozone layer is healing. By mid-century, the hole will be gone. The story of ozone isn't just a science. It's a proof that when the problem is global, invisible and terrifying, humanity can still fix it if we choose to.
The best of all, Mario Molina and Sherwood Rowland got their Nobel Prize in Chemistry in 1995 for their work in atmospheric chemistry, particularly concerning the formation and decomposition of ozone. A gas that once smelled like a straw became our silent seed. From a chemist's mark in the small lab to a vast blue halo that protects every heartbeat on this planet. Ozone has always been a paradox, toxic yet life-giving, fragile yet mighty, and maybe so are we.
When the sky began to break, humanity didn't turn away. We came together, we listened to science, we acted. We healed the wound in the atmosphere. That's the lesson of ozone. No matter how impossible the odds are, no matter how invisible the danger is, we still have the power to repair, to restore, to protect. If we can save the sky, then definitely we can save beneath our feet too. The story of ozone is the story of us. Proof that hope isn't something we breathe, it's something we build.